Hello, I'm your teacher for today, Ma'am Amy Calma. Our topic is all about the molar mass of a compound. For our objectives, at the end of this video, you will be able to recognize the importance of determining the molar mass, calculate the molar mass of a compound, and be able to differentiate molar mass from that of the formula mass. Let's define the terms. Atomic number is the number of proton of a chemical element. This uniquely identifies the chemical element, whereas the atomic mass is the number of atom of a chemical element that is expressed in atomic mass unit. This also approximately is equivalent to the number of proton and neutron in the atom. Molar mass and formula mass are somewhat the same. They are similar with regards to their steps and procedures on how to derive them. Their main difference are their units. For our molar mass, the unit is in gram per mole, whereas for the formula mass, the unit is in atomic mass unit. What is the importance of molar mass? This is mostly being done in laboratory setting. Most especially if you want to determine the specific amount of a substance, then we will need the molar mass. It is also important for us to use the molar mass as a conversion factor. We now proceed with the calculation of the molar mass. Here are the steps that are involved. Of course, the first step is to get the unknown, followed by writing the chemical formula of the given, and then get the atomic mass of each of the element that occurs in a chemical formula, multiply the atomic mass with that of the subscript, and get the sum in order to have the molar mass. So we have here the first problem. We calculate the molar mass of carbon dioxide. The first step, we get the unknown. This is the molar mass. For the second step, we get and write the chemical formula that is given. So we have here CO2 for carbon dioxide. The third step is for us to be able to get the atomic mass of each element. So we have for carbon, we have 12.01 gram. For oxygen, we have 16 grams. For the fourth step, we have to multiply the atomic mass with that of the subscript of the element. So we have here for carbon, 12.01 multiply it with 1 will give us 12.01 gram. For oxygen, 16 times 2 will give us 32 grams. And finally, we have to add all of the atomic masses of each of the constituent. This will give us 44.01 gram per mole for the molar mass of carbon dioxide. The next problem is that we are going to calculate the molar mass of glucose. The chemical formula for glucose is C6H12O6. Therefore, the first step, get the unknown. This is your molar mass. Followed by the second step, and this is the chemical formula for the glucose. So you have C6H12 and O6. Then afterwards, we have to get the atomic mass of each of the elements that are found in the chemical formula. For carbon, we have 12.01 grams. Hydrogen, we have 1 gram. And oxygen, we have 16 grams. We then are going to multiply this with their corresponding subscript. Afterwards, we will be adding all of them. This will give us an answer of 180.06 gram. So, if you are going to get the molar mass, it will be 180.06 gram per mole for our glucose. Molar mass in relation to formula mass. Again, as I have mentioned before, your molar mass has the same procedure with that of the formula mass. The only difference is that their unit. So, we have the examples for carbon dioxide and glucose. As you can see, my dear students, the molar mass that we have calculated a while ago was 4.01 gram per mole. So, this is molar mass, because the unit is in gram per mole. Now, if you are going to get the formula mass, the unit will be atomic mass unit. So, it will be 44.01 AMU. Similarly, with our glucose, after we were able to compute that, so we got an answer of 180.06 gram per mole for the molar mass, and we have 180.06 atomic mass unit for our formula mass. Let us now have our self-check. So you have here two problems, namely magnesium sulfate and we have sucrose. They have their corresponding atomic mass and the steps that are involved in computation of the molar mass. What you are going to do, my dear students, is that you are going to compute for their molar mass, and again, you will already see the answers being posted in the video. So this will serve as a guide for you so that you will be able to determine if your answers are correct or they will need to be re-evaluated if you were not able to derive the same answer. Okay? You may pause this video and you may continue afterwards so that you will be able to derive the correct answer. In summary, the importance of getting the molar mass is mostly done in the laboratory setup wherein we want to determine how much of a substance is needed for a particular experiment. And at the same time, it is also being used as an important conversion factor. These are the following steps that are essential in getting the molar mass. Unknown, then the chemical formula, which is the crucial of all of the steps, because if you do not know the chemical formula, then you might derive with the incorrect answer. Then get the atomic mass of each element that is found on the periodic table, multiply the atomic mass with that of the corresponding subscript, and then afterwards, finally, you are going to add all of the atomic masses of each of the constituent element. Again, for our formula mass, we have the unit atomic mass unit or AMU. And the molar mass, we have a unit of gram per mole. They are both the same in the procedure. The only difference is their unit. Are there questions and clarifications? You may message us, your teachers, so that we may be able to address your concern. Thank you and God bless you.